Hi, good morning, everyone. My name is Bo Du. I work in Pfizer, PharmSci small molecule transformational technology group. Um, I'm going to talk about the ACDLabs usage in PSSM, PharmSci small molecule, how they can help us to digitize our scientific data cloud management. This is a slide I found a couple of years ago. It's a good slide to describe the reality we are facing in today's world. This is what we call the dark data problem. As you can see in this picture, we have multiple systems scattered across the whole company or world. We have data stored somewhere on a server, on a laptop, on network share, on some piece of paper, or in people's mind. In order to find it, you will know who is the right person, where is the right location, and if not, you have to ask around, eventually find it. You have to tread through a mud to find the right data for yourself, right? That has been bothering us for many, many years in the R&D space. For 2020, the state of PharmSci data management is in this picture. On the upper left corner, we have data capture from lab instruments, manufacturer equipments, our PCMM, and other systems. On the upper right, we have a lot of informatics system in the company. We have electric lab notebook, we have LIMS, we have mobile devices, some other IT systems, and we have predictive tools in this left bottom corner, and we also have reuse cases. Those words are pretty much separated. We need a human, we need an expert with domain knowledge to move the data across the borderline and make it usable. It's a lot of work, but people start to get used to it, right? So right at the end of I would say 2018, 2019, PharmSci has started to think about the digital evolution strategy framework. So what we want to do is have a simplified process which can digitally empower people with fair data, and all the data can provide a good foundation for digital technologies, machine learning, AI, robotics, automation, right? And with the data, with the technologies, we want to enable people across PharmSci to do their smart lab, smart manufacture, and smart operations, and eventually have a much better smart development process. So Pfizer built our first scientific data cloud at late 2018. So by 2020, this was the reality. We still have 4 domains: data capture, data use, and the reuse, data predictions. But we decided to use the SDC, Scientific Data Cloud, in the middle and automate the process. So the data capture can transfer data to the cloud automatically. It will be populated into the informatics systems and also shared across the informatics systems. Um, the modeling community can run their tools and send data to the cloud as well. And on the reuse side, we use the data based in the cloud for the visualization and many other decision making work. In the cloud, we want to build a digital library. This is our vision. This ACD Spectros happens to be in the middle of it, and I'm going to share more info, more details in the next couple of slides. This is what we have today. The ACD Spectros platform is a vendor-neutral software platform which can support many different vendor formats and convert data into a open data formats. On the left side, we have 3 labs. Each lab has its own different instruments. Once the experiment is complete, the data will be automatically ingested into the cloud, into the Spectros database in the cloud, right? Along the journey, metadata, some chemical context, and raw data all will be imported into Spectros. Once the data reach to Spectros, it got centralized and standardized. Now you have a digitized contextual analytical data which can be accessible to everywhere on demand. The harmonized data provides the ability to user, which can see other people's experiments. They can access data across labs or across sites. They can use the data for their future decisions. On the right side, this is how data can be accessed and reused. A lot of scientists use Spectros processor. They use workbooks to process CDS data, mass spec, AMR, and any other data. Luminata is a tool we just launched a couple of years back. It's a good tool for project leads to overview the projects. It's a very good CMC decision tool for analysts as well as project leads. Catalyst D2D is another tool we are piloting right now. That's why we have a dashed line connected to it. I will talk more details about it in the slides next. This slide shows the timeline of our journey with ACDLabs. We started at the second half of 2019 until today. And I'm going to break it down into multiple phases to describe our journey with ACD. So this is our first rodeo with ACDLabs. The question asked is, can we take all the Empower data into one place outside of Waters? Reason being, the Waters Empower is too old. It's not efficient. It's really hard for scientists and other users to find information across different projects, across different sites. So we work with ACDLabs to build this new workflow at the end of 2019. User goes to the lab, run their Empower. Once the experiment is done and being processed, the ACD automation server in the cloud will pull the data from Empower into the cloud. It will combine the compound structure using the Pfizer internal structure database, and it will also combine other metadata pieces into the records. Once the data reach the cloud into Spectros DB, user from different sites can visualize the data. They can do their post-processing and many other things. In addition to that, we also export the data into the third party. In our case, it's the AWS Redshift. So we can combine the data into a structured way, which provide a powerful platform for the AI and ML. And we can also build a lot of visualization tool on top of the data. Our modeling team can also use the data from Redshift for their data predictive purposes. Through this new workflow, we are able to leverage the Empower data to do many different things. To name a few, ACD provide a very good tool for the structure and substructure search. I can show you in the next slide. We can also use the data in Redshift or SpectrusDB to do data trending. For example, system survivability studies. The management wants or project leads also wants to build a dashboard to see the usage matrix of Empower and other CDS system. This is a screenshot of structures-enabled search. Right? In the ACD software, you can use CamDraw or CamSketch. You can draw a structure of a chemical or substructure. Then you can just search based on that. You can ask across multiple sites, across different departments, has anyone done experiment on compounds with these structures? And it will show on the right side, it shows the result. It has a list of all the history of compounds with such structure. And if you go through each one by one, you will be able to see the spectrum. You will be able to see the metadata information and with the completed compound structure. This tool provides an easy, faster, automated, and central access to the LC data and the metadata that connected different databases in Pfizer. We used to have multiple sites before ACD workflow. People in UK, if they ever need to find something, they first search their domain and then they need to log out and log into the US domain and find and do another search. It's really hard for them. The data search capability now make life much, much easier in the analytical space. After Empower, we work with the ARD SAG group, the structures elucidation group. The business requirement is we need a way to get all the AMR and mass spec data from different places into a centralized location. Before the workflow was rolled out, the old work style in our SAG group is user will request an experiment using a submission system we have in the SharePoint. The SME will run the AMR and the mass spec results and give the results back to the requester in email. The scientists who request the sample will then use a native vendor software or other third-party software, or sometimes a pen and paper to do the analysis. And once it's done, they will send it, type in the results into their lab notebook and send down to the chemist for analysis. This smiley face is showing people were okay with it, but what was challenging is that during this phase, you can obviously see this is a tedious phase with a lot of manual work, with a lot of data passing down from one group to another. So the value-added data can be spread across different sources. It requires multiple tools due to the nature of the data. If the instruments are from different vendors, you need to thermals or Bruker or other vendors, you need different software. There is no way you can do a structure search under this scenario. The data sharing is very challenging. As I said, either email or you send that in Teams chat, and there is no guarantee to prevent duplication of structures. Sometimes a sample has been performed and nobody knows it, and it has to be sent to run another scan again, which is a waste of time and a resource. And the last not but least, the multiple data formats making this aggregated data analysis very difficult. This diagram shows the new automated structure elucidation workflow. Thanks to ACDLabs, users still submit their request through the submission system, but the difference is now we have a workbook client installed on the desktop. User can directly process that and visualize the data. Once it's done, they can push the raw data to the scientific data called raw data S3 bucket. They can push the process data into the SpectrusDB enterprise in the cloud. If the data is good, they consider it's a golden data sample. They can even promote it to this training data set, which can be used for future reference or comparison. The end user can then see the data through their ACD client. They can use Workbook to do more processing and push or update the data in the cloud. With this new workflow in place, it makes it much easier for global access of the data. It definitely increased the efficiency. We no longer need multiple vendor software to visualize the data. It helps the project tracking. And last but not least, the automated workflow make it more consistent. The turnaround time is much faster. For the end user, they benefit from the gold standard training database, which contains the mass spec and AMR. They can search by multiple metadata piece. They can search by the PF number. They can search by structure and substructures. They can do the spectral matches using the ACD tool. And then all the AMR and the mass spec data becomes a building block for other usage, for example, Luminata. We are still working with ACD on some improvements. There are a couple of features we want to have. To name a few, we want to improve the local processing performance. So in the past, the data got imported into the cloud directory, but the user wants to have more local processing time before they can push that to the cloud. That's why it's on demand. That's the requirements here. We also want to improve the submission system. We want to change from the SharePoint submission to some other web-based automated submission. This is for the SEC projects. Our third phase is working with our drug product department on the powder X-ray. The business request is to have a way to automate the powder X-ray scan integrated into SpectrusDB. So once the powder X-ray experiment is completed, the automation server takes it, follow the same style as I mentioned earlier into SpectrusDB. The majority of people from our DPD department is to use the ACD software to find and compare global powder X-ray data, which was scattered across before this workflow was rolled out. They can run metadata searches using numbers, structures, substructures, and other customized metadata piece. There is a small portion of the user, they want to combine the powder X-ray with other solid state analysis to build a reference database. This is what they had envisioned. This is a drug products department solid state analysis dashboard. On this dashboard, you can see this is the grouping of different compounds. On the left bottom of the page, it has DSC and the TGA analysis for the same compound. And on the upper right side, this is the powder X-ray overlay of multiple spectrums. And this is the metadata, like the peak and a few other things from each compound. Last not but least, we also have the microscope images attached to the same form. The benefit of doing this is scientists can share data more easily. It avoids the awkward email attachment or just sending people the path on the web location, which is our network drives, right? The data is not secure there. Everybody has access to the web location, so sometimes a mistake can change the path or erase the data. Now data can be easily accessed simultaneously by multiple people, and we no longer need to user no longer need to build the ELN reference links. It's automatically linked associated to their notebooks. This workflow also helps collaboration between external vendors. It helps to load old legacy data, and also it can easily combine the simulated patterns into the records. Okay, with all the building blocks in place, at the end of 2023, we decided to build Luminata, which is our data management tool with ACDLabs. This is our vision, how Luminata should play an important role in our R&D space. We want to build this digital library, which contains multiple data sources, multiple data sets. So everything in one place, which can greatly help the decision making. Due to the sensitivity, I blurred the background. This is how Luminata is used today in Pfizer. Project leads on the left side, you can see project leads build at the top level is the project compound. Under that, each subtree is represent a different subcategory. For example, it has the API or drug product, or the stability study, or synthetic routes, right? This is the process map in the middle. So you can see there are multiple steps to synthesize this compound. If you click on each of the steps, you are going to see a list of byproducts or impurities. And click on each byproducts, it will show the analytical data down here with the supporting data such as mass spec or AMR. That's why I mentioned the SEC workflow provide a building block for Luminata. So this is also the analytical results. Building the record takes time and the knowledge, but once it's built, it provides a easy, fast, and centralized access to batch tracking for impurity control and the stability study, for stagnation, compound genealogy, and many, many more. In PharmSci, we use Luminata for different use cases. It's been used for process development. It's been used for impurity tracking, force degradation, and also study of the excipients. We found out Luminata can greatly minimize the time wasted on moving data. Once the record set has been built, searching, using, sharing the data across different users, different sites is much more efficient. I'm going to just name one case study in this slide. This is a screenshot of force degradation workflow with Luminata. On the left pane, you can see a list of compounds under study. If you drill down on one compound, you're going to see subcategories. We do degradations for API, for drug products, different drug products. And under drug product, you can see different techniques being used. We have force degradation with light or thermal humidity, or even with modeling predictions, right? And then click on each one, you can see the compound under investigation, and you will see the observed degradants. And on the right side, it has a degradation project map. You can see the hierarchy of each compound under study and the status of it. Is it complete or underway, or it's about to be start? Another use case of Luminata is our chemical research department uses it for high throughput in process optimization. In the past, scientists compile their sampling information in the spreadsheet. They use the LCMS to do the data. Once the data is completed, they used to analyze the data with other software vendor or third-party software, and they have to manually compile the information, select the optimized conditions, and then manually put that into some spreadsheet. It takes days, hours to do it. With the new workflow with Luminata, they still prepare the sample information, they still go to the lab, do the experiment, but once they complete, the data will be automatically processed by ACD automation server into SpectrosDB. The scientists can still reprocess when needed, but at the end of the day, they can just easily click a button and ACD software will help them to combine and summarize data and select the optimal conditions and export in one spreadsheet for the downstream users. It saves a lot of time. This is our latest phase working with ACD. We are trying to use that for the high throughput experimentation. The goal is to increase the efficiency in experiment design, execution, and excuse me, data analysis. We are trying to use Catalyst to get a consistent calculations that in the past, user have to use different software to calculate the results. In a lot of cases, the data was not consistent. We have to have a second pair of eyes to double check or sometimes even triple check the results. The software, ACD software now provides the consistency on the data quality. It also provides a user-friendly interface that will make the new user easy to get up to speed. It shortened the training time. This is how the Catalyst interface looks like. This is the experiment design page. So on the left side, you can do the integrated materials for reaction building. In the middle, you can do the reaction design. Each steps how you want to design the reaction, and then you will be able to see the summary of the materials in the table down below. Once you've completed design, this is the review and the reprocessing page. This is a 96 well experiment. Click on each well, you will be able to see the analytical results and the plots on the screen as well. So this piloting is still ongoing. We're going to get some conclusive results by the end of Q1 2026. I know it's a long presentation, and this is my last slide. We have been partnered with ACDLabs on this journey for the past 6-7 years. We started with one simple goal, which is to get all the Empower data in one centralized place and provide structured and substructure search. But we soon realized this platform has so much potential, and we snowballed to other data sets one after another until today. We realized the integrated workflow can greatly accelerate our data reuse, data analysis, and it will help our machine learning and AI goals in the future to come. Pfizer Scientific Data Cloud and SpectralDB provide a centralized platform, which make it much easier to share the data across different sites, different departments. It harmonizes the data from different vendors. Scientists can easily use the data by searching under different filters, different metadata filters. They can perform the structures and the substructure search, which is a key feature that ACD can provide. What's next? We have a few near future goal. We want to have all the CDS data in one centralized place. Empower, Open Lab, Basilian. For the DBD user, they want to have a solid state analysis dashboard, which I showed you earlier, the DSC, TGA, FR, maybe solid state AMR, and many other techniques into one place. We want to have a web-based thin client to share the data so that user no longer need to download and install the fat client as of today, right? The benefit being whenever there is a release new feature, it will be much easier for the end user to benefit from it rather than having to download a new installation package. So that's our future plans, definitely more to come. And we will continue working with ACD on that improvements.